Helium is a fascinating element. It holds the second spot on the periodic table. This means it comes right after hydrogen. Its chemical symbol is simple, He. This tiny atom plays a very big role in science and technology. Its atomic number is 2. This tells us that an atom of helium has 2 protons in its core. Helium is also the very first member of the noble gas family. These gases are known for being quite unreactive, and helium is no exception to this rule. The structure of a helium atom is quite straightforward. At its very center lies the nucleus. This small, dense core contains 2 positively charged protons. In most common forms of helium, the nucleus also holds 2 neutrons, which have no charge. Orbiting this nucleus are 2 negatively charged electrons. These electrons occupy a single energy shell. Importantly, this outer electron shell is completely full. This particular characteristic, a full outer shell, is the primary reason for helium's distinctive chemical behavior and its famous stability. Helium is classified as a noble gas. This special group of elements is known for its reluctance to participate in chemical reactions. Helium, true to its noble gas nature, is exceptionally unreactive. It shows little to no inclination to form chemical bonds with other elements. The reason lies in its full outer electron shell. With this shell complete, helium has no desire to gain any more electrons. Similarly, it is very unwilling to lose any of the electrons it already possesses. As a result, helium prefers to remain solitary, making it chemically inert and remarkably stable. When we consider helium's physical appearance, it's rather unassuming. In fact, you cannot see helium at all under normal conditions. It is a completely colorless gas. It also has no smell, so your nose will not detect its presence. Furthermore, helium is entirely tasteless. Another important quality is that helium is non-toxic. This means it is safe to be around, though breathing it in large quantities can be dangerous by displacing oxygen. At standard room temperature and pressure, helium exists as a gas. It is significantly lighter than the air around us, which is why it has a natural tendency to float upwards. Helium possesses a truly extraordinary property related to temperature. It boasts the lowest boiling point of any element known to science. This boiling point is an incredibly frigid -268.93 degrees Celsius, or 4.22 Kelvin. This temperature is just a few degrees above absolute zero, the theoretical point of no atomic motion. Because of this incredibly low boiling point, helium remains a gas under almost all conditions on Earth. Transforming helium into a liquid requires extreme cooling. It is one of the most challenging substances to liquefy, a testament to its unique atomic interactions. This characteristic of extreme coldness makes helium invaluable in specific scientific fields. Scientists harness liquid helium for use in cryogenics. Cryogenics is the science and engineering of producing and using very low temperatures. Liquid helium is the ultimate coolant. It can chill materials down to states where they exhibit unusual phenomena. For example, it is essential for achieving superconductivity in certain metals and alloys. Superconductors lose all electrical resistance when cooled sufficiently. Liquid helium also has a bizarre superfluid phase where it flows without any friction, a property that continues to fascinate researchers. Hydrogen is another element that is a very light gas. In fact, hydrogen is even less dense than helium. However, hydrogen is fundamentally different from helium in a crucial aspect: its reactivity. Hydrogen is highly flammable. It can react vigorously with oxygen, potentially leading to explosions. The historic Hindenburg airship disaster serves as a stark reminder of hydrogen's volatile nature. Helium, in complete contrast, is exceptionally safe. It does not burn, it does not support combustion, and it does not react with other substances. This inherent stability makes helium a far superior and safer choice for applications requiring lift, such as balloons and airships. This inherent stability is arguably helium's greatest asset. It does not cause corrosion when it comes into contact with various materials. It does not trigger unwanted or dangerous chemical reactions. These qualities make helium the perfect candidate for creating a protective, inert atmosphere in numerous industrial and scientific processes. Many manufacturing techniques, especially in electronics, require an environment free of reactive gases like oxygen. Helium provides this pristine environment reliably. Its inertness is also highly valued in scientific research, where pure conditions are often necessary for accurate experiments. It truly is a gentle giant among the chemical elements. Many people encounter helium in a very joyful context: balloons. Brightly colored party balloons filled with helium float gracefully, adding a touch of magic to birthdays and celebrations. This happens because helium is significantly less dense than the surrounding air, giving it buoyancy. This same lifting power is utilized on a much larger scale to fill blimps and other lighter-than-air craft. These gentle giants drift through the sky, used for advertising, surveillance, or leisure. Helium literally gives us a lift, bringing delight and wonder to countless individuals across the globe. It is a gas that often evokes feelings of lightness and fun. Beyond the party scene, helium plays a critical, life-saving role in modern medicine. Sophisticated magnetic resonance imaging, or MRI, machines depend heavily on liquid helium. MRI scanners are powerful diagnostic tools that allow doctors to see detailed images of the inside of the human body without surgery. These machines employ incredibly strong superconducting magnets. To maintain their superconducting state, these magnets must be kept at extremely low temperatures. Liquid helium is the only substance cold enough and practical enough to achieve this. Without helium, the advanced diagnostic capabilities of MRI technology would not be possible, hindering medical progress. Various industries also rely heavily on the unique properties of helium. In the field of welding, helium gas is often used to create an inert shield. This shield is blown over the area being welded, preventing oxygen and nitrogen in the air from reacting with the molten metal. This protection results in a cleaner, stronger, and more durable weld. Helium is also indispensable in the manufacturing of fiber optic cables, which transmit data at high speeds. Furthermore, it plays a crucial role in the production of semiconductors, the tiny chips that power our computers and smartphones, by ensuring ultra-clean environments during fabrication. Space exploration and atmospheric research represent another major area where helium is essential. Rocket propulsion systems use helium to purge fuel tanks of residual, often hazardous propellants before launch or during stage separation. It is also used to pressurize the fuel systems themselves, ensuring a steady flow of fuel to the engines. Large scientific balloons filled with helium carry telescopes and other instruments high into Earth's stratosphere. These high-altitude platforms allow scientists to study weather patterns, cosmic rays, and astronomical objects with greater clarity than from the ground. Helium truly helps humanity reach for the stars and understand our universe better. In the grand scale of the cosmos, helium is incredibly abundant. It ranks as the second most common element in the observable universe. Only hydrogen, the simplest element, is found in greater quantities. Stars, including our own sun, are giant factories for helium. They produce it through the process of nuclear fusion, where hydrogen atoms are forced together under immense pressure and temperature to form helium. This process releases the vast amounts of energy that make stars shine. Helium is, therefore, a fundamental component of stars and galaxies, a true building block of the universe. However, the situation here on Earth is dramatically different. On our planet, helium is surprisingly rare and is considered a finite, non-renewable resource. The vast majority of Earth's accessible helium does not come from the atmosphere, but from deep underground. It is primarily a byproduct of the natural radioactive decay of heavy elements like uranium and thorium within the Earth's crust. As these elements decay over millions of years, they release alpha particles. These alpha particles are, in essence, helium nuclei. This helium gas can then become trapped in pockets within porous rock formations, often alongside natural gas deposits, from which we extract it. Once helium is extracted and released into Earth's atmosphere, for instance, from a leaking balloon, it is effectively lost to us forever. Because helium atoms are so incredibly light, Earth's gravitational pull is not strong enough to hold onto them. They gradually float upwards through the atmospheric layers. Eventually they reach the very edge of the atmosphere and escape into the vacuum of space. We cannot manufacture helium economically on a large scale to replace what is lost. The demand for helium is continually increasing due to its irreplaceable properties in many high-tech applications. We are therefore consuming our limited global reserves at an accelerating rate. Consequently, it is crucial that we prioritize the conservation of helium. This remarkable element is far too precious and vital for many critical applications to be wasted. The use of helium for frivolous purposes, such as filling party balloons, is increasingly being questioned by scientists and conservationists. Critical sectors like medical imaging, scientific research, and specialized manufacturing have a much greater need for it. Implementing widespread helium recycling programs is essential. Furthermore, researchers are actively exploring ways to use helium more efficiently, or to find suitable alternatives for certain applications, although its unique combination of properties makes it very difficult to replace. Responsible stewardship of our helium resources is paramount to ensure that future generations can also benefit from this cool, indispensable gas.